Hello friends, welcome back to Concept Clarity. Today we will talk about addition of vectors. In the previous class we saw the basic of vectors, which has both magnitude and direction of vectors. Addition of vectors. So let us understand in brief. Let us say we have an object which moves from point A. This is point A, and the object moves from point A to point B, and then from point B, I'll show it with an arrow. It moves from point A to point B, and then from point B it moves to point C. If this is the direction of the movement, then this slight misaligned, then this arrow here from A to C is called as the resultant movement. This shows the resultant movement. It moved from A to B, B to C. This is the resultant movement from A to C. Right? This is a vector A, this is a vector B. Then C is a resultant of the vector sum of A and B. So here the order of addition is not important. The order of addition is not important here. A plus B is equal to B plus A. It is nothing but C, nothing but C. Okay. So now if you observe here clearly, let us take a new slate. If you observe this particular diagram, I will take it again on a new slate. The movement is from A to B and B to C. Then the resultant vector is from A to C, denoted as C, and this is B and this is A. If you see here, the tail of this vector is touching the head of the previous vector, and the resultant vector, the tail touches the head of the final point of the vector. Right? So this is called as the triangle law of addition. This is called as the triangle law of addition. Addition of what? Addition of vectors. Right? So let us go to another case. Let us now displace one of the vectors such that the tails are at the same point. Let us displace the vector such that the tails are at the same point. So if you have a vector, this vector A, now this vector is displaced at an angle theta. It is displaced at an angle theta. So because it is displaced at an angle theta, you will get another vector B. When the tails of two vectors, these are the tail of the two vectors, at the same point, then the smaller angle between the vectors is considered as the angle between the vectors. Okay, the smaller angle is considered as the angle between the vectors. If we now draw parallelogram, let us draw parallelogram. This is the resultant vector here, which will come out like this. This will be parallel to this. This one will, the top arrow will be parallel to A, and this not perfectly, but this will be parallel to B. Okay. So the what is this? This is a parallelogram. The diagonal of the parallelogram contains the tails of the vectors. tails of the vectors, right? And this is the resultant vector, right? The diagonal is the resultant vector. This is the resultant vector C. The length of C is not equal to the sum of the length of A and B. The length of C is not equal to the length of A plus B. Okay, this is not the case. This is not an algebraic addition. It's not a algebraic addition. The magnitude of the resultant, the resultant magnitude depends upon the angle between the vectors as well, right? If we consider this triangle, let us take a new slate again. If we consider this, if we consider a movement from A then to B, then this is the resultant C, this is B, this is A. If I extend this line here, I'll say this is theta, then this will be 180 minus theta, right? So based on this triangle, if I draw a perpendicular here, this is A, this is B, right? This is a resultant. Now I draw parallelogram. So what I do? I draw one parallel arrow here. This is parallel to A, and another arrow parallel to B. Okay, something like this it will look. Okay, this is B, right? And this theta, because it is parallel to B, this will also be theta, and this will be another angle called phi. Okay, so this side here will become B sin theta, and this side here will become B cos theta, right? So using the cosine rule, we can say that C square is equal to A square plus B square minus 2AB cos of 180 minus theta, and this will become equal to, hence C can be written as square root of A square plus B square minus plus 2AB cos theta, right? Because in the second quadrant, this is the second quadrant, in the second quadrant sine is only positive, cos is negative, so minus minus will become plus. This gives the magnitude. So it is not equal to A plus B directly. It is not equal to A plus B or magnitude of A plus B. It's neither equal to A plus B. Okay, it's due the resultant, the magnitude will be due to the angle between the vectors as well, right? So what is this phi? This phi can be written as tan phi is equal to B sin theta divided by A plus magnitude of A vector plus B cos theta, right? This is the angle. So let us see some cases now. Let us see some few cases. Next, I'll wipe out this. I'll clear this out. We'll take some few cases. We have the formula, resultant vector formula is equal to square root of A square plus B square plus 2AB cos theta. Okay. Now when will R be maximum? First case, R max. When will it be maximum? When cos theta is maximum. And when is cos theta maximum? Cos theta is maximum when cos theta minus 1, no, minus 1 means negative, right? It has to be equal to 1. When cos theta is equal to 1, when theta is 0. When theta is 0, that means vector A and B vector, that theta is 0 degree. So resultant vector is C. So the maximum value of the resultant vector is given as R max is equal to, what will you get? You will get it root of A square plus B square plus 2AB, and this can be written as square root of A plus B the whole square. This will become equal to A plus B. So the resultant is maximum when theta is 0. When will it be minimum? Next case is minimum. Now R minimum, R is equal to minimum. When will R resultant be minimum? When cos theta is minimum. And cos theta is minimum when cos theta is minus 1. And when cos theta is minus 1, when theta is equal to 180 degrees. At 180 degrees, theta is, at 180 degrees, cos theta is minus 1. That means what is the case here? Here you have a vector A, this is vector A, and the other vector B is opposite to each other. It means theta is 180, right? Theta is 180. So this is a resultant vector C. So resultant minimum is equal to magnitude of A minus B. Another case is when theta is equal to 90 degrees. When theta is equal to 90 degrees, what will happen? Cos theta will become equal to 0. That means we have a vector A and the other vector B is perpendicular to each other. That means this is the resultant vector R. In such a case, resultant is equal to square root of A square plus B square after you solve that equation. So now let us see about subtraction of vectors. Okay, I will clear this. These were some of the cases for vector addition. Now we will see subtraction of vectors. Subtraction. What is subtraction of vector? Subtraction of vector, if I have to write A vector minus B vector, is nothing but addition of the negative of the B vector, right? The addition of the negative of the B vector. Now if I have a case, I will clear this or I will take it here itself. If I have a case here, this is vector A and this is vector B. Sorry, this case we have seen. We will see another case. I will clear this out. We will see another case. I have a vector A and I have a vector B this way. Right. So now what happens? Now if I extend this line here, right, this will be this is a projection from here. Right. This angle will be theta, same as this angle theta, and this angle here will be 180 minus theta. right? So basically what happened was, this vector which was b on this side got reversed on this side as negative b. So then what will happen to the resultant? The resultant will be the addition of the negative. So resultant will become equal to a plus minus b. So this can be written as a minus b. But what is the actual magnitude? The actual magnitude will be written as r. The resultant will be equal to square root of a square plus b square plus 2ab cos 180 minus theta. So now r will become equal to square root of a square plus b square minus 2ab cos theta. This way how we are supposed to do the subtraction of two vectors. So the earlier addition was basically in the earlier case what we saw was basically the addition of the vectors, right? Here when we reversed it, we have to put minus sign here to find the resultant vector. So this is all about vector subtraction. So next we are going to take up some problems on vectors. So stay tuned, say subscribe so that you can continue to watch all subsequent videos. See you until then, bye.